Hello everybody. Hello everybody. We are in this video to talk about JSON data and geodata, spatial data. JSON data in Exasol in the newest version is very easy to access, and for geodata we have a geometry data type. What I want to show you now is how to import a file with the format GeoJSON. That's basically a JSON format that contains points, polygons, lines, something on Earth. But before we do that, I have here a little example table that is called universities. And I insert the OTH, University of Applied Sciences in Regensburg, and that's the geo coordinate. Latitude, longitude, it's of the type point. So inserting data into a column of type geometry simply works as a varchar, as a string, and a constructor is used depending on which type of geodata it is. Here it is a point. And now I have this point here. A nice feature in dbeaver, this is the SQL client dbeaver, is you can click on a geo position, and then here on the right you can click on Wert or value. I already did that, so typically your data looks like this or that, don't know. If you click here on value, then you can see the position on a map. You can also open it in a browser to make it bigger and so on. And the nice thing is, if you select multiple ones, you have one map with multiple points or polygons or whatever areas. Okay, that's a simple table where points of interest have a position. I want to add a column in which city is this. Therefore, I found a data source on by googling GeoJSON Deutschland. This is a data source with multiple resolutions, so you can have it very detailed or space saving. So I downloaded the one with the most data. So this only contains, I think, the polygon with Germany itself. Then the next one contains for every state one polygon. So for every Bundesland 16 in different resolutions. And I want the finest one with cities or with districts. So here's a file. I downloaded the middle one because that, not the image, because that one is less than 2 megabytes. 2 megabytes because I use a trick here. Varchar has a limit in Exasol, the data type varchar, of 2 million characters. So that's 2 megabyte. And the trick is to simply load the whole JSON data into that single column in a single row of a table. So I will create a table with one column, one row, and put the whole GeoJSON there. And then I do the rest of the processing in the database. For other approaches, this is not feasible because the data is larger than 2 megabytes. Then the possible solution must be writing a Python program that opens the file and traverses, iterates over the elements in the JSON array and so on, and then creates either new files which are smaller or accesses the database directly or something else. So I will show you how to import the file when it's less than 2 megabyte. So I can download the file by clicking download. Best is right clicking it and save on disk. because when you just click it here or here, it opens in the browser. Let's do it. 2 megabytes is not so large. The browser can do this very well. You see, this is how GeoJSON looks like. Basically, GeoJSON example. Here you see some examples. A point looks like JSON object, then the type is point, and then coordinates is an array of longitude, latitude, for example. Or here, polygon, type polygon, and then a coordinates is an array of points. So an array of array, and the inner array is again longitude, latitude, so x coordinate, y coordinate, and then the array are the points of that polygon. Okay, and our base element, so it's only one JSON object. That's the problem why we need everything in one batch. This is type feature collection, so multiple things together, multiple features. Each feature has a type, and each so it's feature. Each feature has properties. These are descriptive elements, like this is here a city called Oldenburg. Name 3 is the property where we find the city name. Name 2 is the district. Name 1 is the state, the area, and name 0 is, well, I think always Germany. It's the country, because we only have German data here. And then properties closes here, and then we have geometry. And geometry is type polygon. For some cities, the type is multi-polygon, because these are cities which are not one single polygon, but multiple of them. I don't know why. Which cities are separated as multiple polygons, but I saw in the data that there are also multi-polygons. Let's search here. Multi-polygon Wesermarsch. So a multi-polygon is an array of an array of an array of an array. So this is the longitude latitude array. This is the array that has all points, and then this array has as a second element, so as a first element the points of the city, and the second element holes, so a city that has nothing that belongs to the city in the middle, and then the other array are the collection of those polygons. So it doesn't matter. So let's import this file. I already downloaded it on disk, so it is called 3 middle GeoJSON, and the problem is here are line spaces, and when we simply use the import from CSV, basically import from CSV is a workaround here, because we don't import CSV files. We load a text file that contains JSON, but Exasol has a nice CSV import feature, so I simply misuse that. Let me show you an import command. To this I will come later. One moment. Here. I create my table called geoimport, which is just a table with one single varchar column, and I want to load the full string in there. So select star from geoimport is just a stupid table with one varchar column. Then I downloaded the file, and then I asked ChatGPT Linux command to remove the new lines from a file. Put result in a new one-line file. So a simple command that, let me show you the file. It is here. So I have this original file, and it has multiple lines. And the problem in this import is it imports one single line and then the second line and then the second line and then the next line. Yeah, one possibility is to simply import it like that and then use group concat or something. Well, let's try it first of all without this command. This was my solution. I convert the file into a new file, and that new file has only one single line containing the whole data. So let me try if it also works without doing this pre-processing locally. So first of all, I copy that file into my home folder, because for some reason my dbeaver is not able to access files in a different folder. So it is called 3 mittel underscore no dot geo.json. I import it, and the result looks stupid because in the first line there was only the opening parentheses, and then in the second line, and then in some lines is nothing. So we can skip the lines where it's nothing, where v is not null. Then we have everything here, and I remember why I did not do it like that, because when I now use group concat, we lose the order of the lines. So importing a CSV file, which is not a CSV file, doesn't preserve the order because tables in Exasol do not have an order. So this is unfortunately not the solution. So I need to convert this really locally here. So again, my file looks like this, multiple lines, and now I execute this command. So the new lines are deleted. So my output is called geo.json, and it's only one single line that contains the whole data. And again, I copy that into my home folder, and now again I try it with geo.json. I truncate the table before I do that so that it's empty. Now I import it. You see here I use tricks. Column separator is typically the separator that is used for the CSV file. So typically you have Peter, comma, Miller, comma, something, or Peter and then dash or some other column separator. I simply use a dummy value here. This is an ASCII or Unicode separator, which is never used in the file, just a stupid value, so that it can be imported as it is. So I now import the whole data. I executed this command already. No, truncate I executed. Now I import. Updated rows 1 because the file has only one single line with all data, and now I see this row. I truncated it after 100 chars because I don't want to see the full 2 megabytes here. So now Exasol has built-in functionalities for accessing JSON data. So here's the JSON extract function, which was added in Exasol 7. Documentation is here. JSON extract. It takes as an input a JSON string. So this can be a column of a table where JSON is found. And then multiple things that we want to extract from that JSON string. This is used to extract something that returns a table of data. So multiple cities, multiple rows. There's also JSON value which extracts only one single value out of an JSON field. So this is a JSON field. This is the expression where we want to extract something, and then we need a definition which looks like a column definition of create table. So a column name and a data type. It defines how the result will look like. Here are examples. Here's JSON data. I want to dollar is always the root, so the full JSON. Then we go into the sub element data. So you see this is an array, and then country, and then customers, and from the customers a name. And when something is ambiguous, so it would return multiple values, then you use this hashtag symbol here to unnest it, so it will return it for every single element. Okay, for my example, I have a very simple example here of JSON extract. I have a document, a JSON object with one field called data. It is an array, and the array again has objects, and these objects have the field A and B with integer numbers, and then a second object. Okay. Now I want from this the data A and the data B emits A int and B int. So these are the two columns. It returns this. So it converts JSON data into relational data. Now I do the same with my geo import table, which I created. Because this is one single row with the whole data. Data is in the column V. I want features, properties name 0, 1, 2, 3. So this was the city name, this was the country name, Germany, and so on. And I leave out this one because this doesn't work. We will see later why. And I will show it as a table. Very nice. That's the data from the source that we imported. The problem with this features geometry is JSON scalar required. It would be nice if something, so here geometry, that is not of a scalar type. Scalar means a string, an integer, so something that can be directly converted into a SQL scalar type, varchar, integer. It doesn't support arrays and it doesn't support objects in JSON, but this geometry unfortunately is a is a JSON object, so this does not work. So I comment this out, but I will nevertheless not use this here. If it would be possible to use that, I could use from the documentation from Exasol a little script. This is from an old Exasol version, geospatial data. It's a workaround. Here you see it's no longer supported. It is a workaround to convert one single GeoJSON object into a SQL geometry string. The magic behind that is in a script that can be downloaded here. Here stgeom from GeoJSON. It is a script written in Python. It uses JSON to extract the given data and then converting it into geometry by simply looking on the field coordinates and converting the array of coordinates. The first element is the latitude and the second the longitude, or the other way around, I don't know, into this syntax with a space as a separator. So, but this can only be used for one single object, and it was not possible to convert that JSON data into smaller JSONs that only contain the geometry, the polygons and so on. But nevertheless, let's create this script. The only thing that I changed from the script on the website is create Python 3 scalar script. Python 3 is the language that is used. The original one from the documentation from this website uses Python, which is Python 2. The script is called stgeomin from JSON. It takes as an input one scalar value called g, and it returns one scalar value, a varchar. Yeah, it's simply the conversion from a JSON into a point, opening brackets, and then the coordinates, for example. Okay, I created that script, and an example usage would be giving this GeoJSON point, that was the one from Google here, and it converts it into this syntax. This is not a geometry object yet, this is simply a varchar, but we can use cast, that one, as geometry later to cast it into a geometry, or simply insert it into a table where the column is of type geometry. Here in that column, it's not only the university's table, it's not only geometry, but also a spatial reference ID that defines the coordinate system. The best practice is 4326. There's a table called Spatial reference systems. Google Spatial ref sys. Oh, okay. Yeah, so there are many spatial reference systems. Each one has a spatial reference ID and a description. Some of them are only valid for points on specific countries or specific areas. Some are good for distance computation. Some are good only for Mexico data. Some are good for data which is close to the North or South Pole. Some is better for data that is next to the equator and so on. So it maps longitude, latitude values to which are on a globe. The Earth is a globe, which maps it into a two-dimensional space map. Yeah, and the most important thing is to use the same every time. So I use here 4, 3, 2, 6, and I always will use this, and then no problems will occur. Problems will only occur if you use different ones and then you use distance, or is an object within another object and the one object is in that spatial reference system and the other in the other, then it does not work. Okay, now my example should show where was this point? Yeah, this point is converted into a point object. The point is given in the coordinates array, and the polygon, as we saw, will be converted into this. But as I said, we don't have points and polygons directly in our table. We have a lot of data, a feature collection in the table. That's why I simply took this script again. That's exactly the same script, the script from this import from Geodata this one here, and I added or I changed some lines. First of all, it is still a scalar script, so it takes one big JSON as an input, and it now does not return one single geodata, but it emits multiple rows, and each row has a country, an area, a district, a city, and geo. So as you can see, the script from before, from the Exasol website, was very generic. It could convert any GeoJSON into point, polygon, into this SQL syntax that we need. This one here is made for my use case. I want to return or emit. Return means like a function in Java or Python that returns only one value. Emit means it emits multiple rows. Yeah, and each row has a country, district, area, city, and the geometry in that format here. The original script had this conversion. I leave this as it is. And the original script had this run function which takes the parameter, calls it geo, and then it converts it into the SQL syntax. I take the parameter and I call it not geo, I call it JSON data, and I use a for loop for feature in JSON data features, and then I access. So now this is a Python dictionary, and I can go into the field features, which is an array, and I iterate over this array and call each element feature. Go into properties, name 0. This is the country, this is the state, district, city name, and from the field geometry I can access the geometry data, which is JSON, and the rest does the function from above, which takes this. No, it's not JSON, it's already Python dictionary. It's already converted. It will convert it into the string. So it emits 5 columns. Okay, here it is. And let's only execute this select command here. Country, area, district, city. No, let's start with this select command here, the most inner one. Select cities from GeoJSON, that's the script that I wrote here. It takes we remember this one here was the long GeoJSON collection. And I put this as an input to our cities from GeoJSON. It returns a big table with country, area, district, city, and our geodata, and that's it. But this is not geometry, this is varchar. So I put this select into a subselect, country, area, district, city as it is, and then cast geo as geometry with the same spatial reference ID. So it looks exactly the same, but now let's click on Osnabrück. It is not a varchar, not a string. It can be displayed on the map. You see where Osnabrück is. So I store this, I persist this into a table called cities. So I can now take a look in the city table. Okay, I can find all cities in the district Oberpfalz. Here you also see Regensburg. Oh, that's the string, that's the geo. And there you see what a whole is. This is a polygon. Don't know if it makes sense to copy paste here because it's a lot of data. Each polygon has a point xy, next point xy, and this is in an array. And when this array is finished, then a second array describes this hole, the coordinates of this hole in the middle. Because we see here we have Regensburg and we have Regensburg-Städte, so the inner city. If I mark both, then both is selected. If I mark everything here, then I have everything on the map. And now let's complete the example with the example from the beginning. I had a university table which has universities and a geopoint, and I want a column with a city that has this university, and therefore we need a GeoJoin. GeoJoin universities join cities. Here, universities join cities on st contains. There are many functions to work with geodata. They begin with st. I think this is spatial, temporal or something. The first one contains the second one. So does this polygon contain the point? If yes, then it returns true. Then the university finds this city as a joint partner. If it doesn't contain, then not. So I search for every university. We only have one, the joint partner in the cities table, where the polygon is containing that university, and that's how we can enrich our data, which had longitude latitude values where the university is, with city values. And we can of course also say country, in which country is it, in which state is it. I did not call the column state because state is an SQL identifier and SQL keyword, and we had district here. That's it. That's how you can access JSON data. As I said, this workaround here only worked because the data, the file that I imported, was less than 2 megabytes large. Otherwise it would say, oh, it is longer than this varchar 2 million. Then you need to split the file into multiple files first. Or you need to use a very different approach that doesn't import it, like we did here. I imported the whole file to have this geo import table. Write a Python script or so that connects to Exasol. It is possible to let Python talk with Exasol with a script called PyExasol. Pip install PyExasol. Then you establish a connection with a host name, username, password. You execute SQL commands, and then this is a Python dictionary or row. This is an array that is returned by that statement, an iterable. You can iterate over the result, but the nicer feature is connection dot export to pandas, execute a query, and the result is a pandas data frame. And then you can work with this pandas data frame and work with the data that it's read from the database. But we wanted to insert data into the database, then simply use execute commands with your data. Okay. I said okay very often. See you then.